Hello. Okay, so let's get started. Okay, so I don't think you noticed, but actually I had to delete this video and redo it again because some of the calculations that I did were wrong. But don't worry about that for now, because you never noticed, to be honest. Let's go for the problem is somehow I got the wrong answers for when I did I square root the number, but anyway now it should be fine. And I didn't want to show you a video with wrong numbers, but anyway. So today we do complex numbers. And these complex numbers are used in AC circuits for when doing components. And you may wonder why do we do that? Well, as you remember from the, just a second so I can grab only one piece of paper. So as you remember from the first week, we did something similar to this one, we did like an AC, just like that, and we had a capacitor, and then we had two capacitors in here as well. Okay, and we did something similar with the one that has inductors inside of it. And you may say, well, don't we apply the same principles for that we apply to two of them? Well, actually no, because this one got an angle of minus 90 degrees in the phase, and this one is got a 90 degrees positive in the phase, the capacitor and inductor. It's okay to do it and the circuit uses the same component for all of them, but that won't really be that good or efficient, because what if you have a simple circuit that's something like this? You have a capacitor, a resistor, and an inductor in series connected. And because this has minus 90 degrees, this one is 0 degrees, and this one is 90 degrees in phase, it will be a lot harder to calculate them, because they have different values. Because if you were to draw it in a graph, the resistor will be at this point like this, then the inductor will be at this point like this, and the capacitor will be at this point like this. They'll be in different phases, making it different and a lot harder to do. And that's why we do complex numbers, because complex numbers basically will allow us to convert these components in a type of number that we can use it to calculate and to determine at which angle is the peak or whatever you need to know. But anyway, there's the basics of complex numbers. We learn them so we know how to calculate circuits that have different components in them, that they don't have only one component inside of them. Alright, so complex numbers, they do have two forms. They have the polar form and they also have the rectangular form. Rectangular form, it's got an x and y axis, basically like that, one up and one down. And then the polar form has a z and an angle, basically the hypothesis of a triangle and the angle that it goes in. If you're curious, I do have an example of them. For example, this one is if in a polar form, if z was 5 and it was an angle of 45 degrees, basically you measure the angle of 45 degrees and you go 5 up and 5 on the y and 5 on the x, and basically you get this value here. And the rectangular form is different, because rectangular form doesn't use the angle, it uses these two components. They use the x, which is 5 in the x-axis, and the 3, which is j, in the y-axis. And so you draw it like this, so you don't really care about the angle. And the answer is well, what if you want to know the angle, or if you don't want to know the angle but you want to know the x value, which is the real number value? Well, to do so is very simple, because we have the conversion. Basically, we can convert any of these four components, x, j, y, z, and the angle, to each other. For example, z is equal with x squared plus y squared all over square root. The angle is equal with tan minus 1 y over x, and x is equal with z cosine of the angle, and y is equal with z sine of the angle. Basically, you can convert them. If you know polar form, you can convert it to rectangular. If you know rectangular, you can convert it to polar. Nice and easy. There is also conversion for j, because j, what j looks and means, is basically square root of minus 1, which is an imaginary number, a number that doesn't exist. And when you square root j, you'll get minus 1, because square root squared, that will simply give you minus 1 or if you want to reverse it to a negative value, you can do 1 over j, and that will give you minus j. Alright. Now what we can do with these complex numbers, we can also add, subtract, multiply, and divide them as well, like you do with normal numbers. For example, in addition, you can easily add rectangular form numbers, which is got the x and y value. Because they don't depend on the angle, you simply add them. You add the x's together and you add the y's together. Same for the subtraction. You don't really need the angle. If it's rectangle, just divide, just take away x1 by x2 or vice versa. And the same for y1 and y2. The only criteria is to keep the y's. For example, if you do x1 minus x2, you can't do next one be y2 minus y1. No, you still need to keep it as y1 minus y2 to keep the consistency. And you can also add in polar form, but addition or subtraction cannot be done in polar form unless they have the same angle. So if like it's got an angle of 30 degrees and you want to add with another angle of 30 degrees, that will still be equal with 30 degrees. The only number that changes is the z number. You'll see that more when we do the exercises. But anyway, so that was the first page, and now on the second page it's got the multiplication and the division. And multiplication and division can be done with both of them, with the polar and the rectangular form. In rectangular form it's a bit more complicated, like multiplication, because it be x1 times x2 minus y1 times y2 plus j y1 times x2 plus x1 times y2. A bit more complicated than the addition, isn't it? That's why when you do multiplication, you prefer to do it in polar form, because in polar form you simply do c1 times c2, it's equal to z1 times z2, and then you do the angle of delta 1, angle 1 plus angle 2. A lot simpler compared to this one, and a lot easier to memorize. The same for division. When you divide two rectangular values, it will be x1 times x2 plus y1 times y2, all divided by x2 squared plus y2 squared, plus j y1 times x2 minus x1 times x2, all divided by x2 squared plus y2 squared. Again, unnecessarily complicated when you also have the polar form division, which is simply z1 divided by z2, angle 1 minus angle 2. Very simple. But anyway, so this video will be a short one as well, so don't worry, because complex numbers are just the foundation of like how to do them, how to add, how to divide, how to take away, and stuff like that. When you're going to like get into more complex number exercises, it's in the next lesson, which I already have already here, because I said this is a re-upload of the original video. So I already have the next video ready to record, which is basically AC circuits, and be AC series, and there'll be also be the AC parallel before we do them combined together. Alright, now let's get started the exercises then, shall we? So I'll leave this page here with the conversion and everything, and these are new papers. My old book finished because we've been writing a lot lately, so I had to like replace it with a new one. Yeah, I don't really like this one. I don't know, it depends if you like it or not. I can see through the page, and that's why I don't really like it. But anyway, let's start with the first one. Converting the complex numbers, and the first one is asking us to convert rectangular to polar, and we have here the formulas to do so. Rectangular are the x and y values, which are given here. C is equal to 6 plus j8, so then z will be equal to square root x2 plus y2, and then the angle will be equal to tan to the power of minus 1 y over x. So let's start with z. So z will be equal with square root 6 squared plus 8 squared, and that one will be equal with, and I'll do it on the calculator. That's why I re-uploaded, because like I don't know how I did them, but I was getting the wrong answer for some reason. So yeah, I didn't want to give you the wrong answers. For example, for this one I didn't get 10, I've written like 3.75, no, 7.35, and I don't know how did I get that number. But anyway, so that is the z value. Now we need to find the angle value, which will be 10 to the minus 1 equal with, and then it will be y, which is 8 divided by 6, and that one will be equal with, oh no wait, multiplied, that one will be equal with 10 minus 1, 8 over 6, that will be equal with 53.13. So 53.13, and remember these are degrees. Alright, so from these two we can deduce that the converted version will be equal with, wait a second, I'll pause here for a second. Okay, sorry about that, the postman came, so I had to like pick up the letters, but anyway, so yeah, this will be the answers, and when we write in a polar form it will be written like this: 10 to the angle of 43.13 degrees. And there you have it. This is the first answer. So this number here, 6 plus j8, is the equivalent of this one here, 10 to the angle of 53.13. And you can already see the similarities here. For example, this 10 can be like the peak voltage, and it will be at an angle in the phase of 53.13 degrees. And we work with similar numbers. And you may ask like, well, why do you need to convert it to rectangular form? And again, it's because you can't really add in polar forms, you know, polar numbers. For example, if you have like 10 to 53.13, you can just add it up like 5 to the angle of 60 degrees, you know. But anyway, so let's keep going. Now let's see, polar to rectangular form, and this time we have 15 the angle of 60 degrees. So we look again at the formulas. X is equal with z cosine of the angle, and y is equal with z the sine of the angle. So then x will be equal with z cosine angle. And don't worry, like when you do the next exercises, these ones will become reflex for to you and to me as well. Like when I was doing the AC circuits, I've been doing these conversions so often, I just memorized them at this point. But anyway, and then I'm just pointing it so you can see it, and then that will be equal to 15 cosine of 60 degrees. So 15 times cosine of 60, that will be equal with 7.5. Okay, and then y it's equal with z sine, there you go, the angle, that's equal with, it's basically the same thing, but instead of cosine you use sine for y, 60 degrees, and that one it's equal with, so 15 times sine 60, that's equal to 25 point, let's just write 26, really, 26, oh no, that's tan, I was a mistake again, it's 13. Okay, so when you combine these two, this is the x value, so that'll be 7.5 plus, and this one is the j value, which is j13. And there you have it, this is a rectangular form. And there are also other rules. For example, like what if the rectangular form has a negative value, has minus 10, how do you do that one? Well, then you simply do, again, we apply the same rules. So z is equal to square root x squared plus y squared, and that one will be equal with square root 10 squared plus 5 squared, which is equal with, it doesn't matter if it's 10 or minus 10, because when you square root something it's positive anyway, no matter the number. So yeah, you can just write it as a positive number, and then that one will give me 11.2, and then the angle is equal with 10 minus 1 y over x, that one will be equal with 10 minus 1, y will be 5 over 10, and remember to put the minus in front of it because this 10 is a negative value, so that will be equal with, so that will be 5 over 10, let's put the minus as well here so we don't forget about it, that will be minus 26.6, so minus 26.6 the angle. So then this one will be, we can write it as 11.2 angle of minus 26.6 degrees. And there we have it, another conversion done. Alright, let's go to the next one, which is polar to rectangular, and that will be 20 the angle of 200. So that's polar, we need to do it in rectangular form, so then it will be x will equal with z cosine angle, and that will equal with 20 cosine 200, and that's equal with, so 20 times cosine 200, that will be minus 18.8, surprisingly enough, and then y is equal with, and then it's the same one, but instead it's a sine, so z sine the angle, which is equal with 20 sine 200, which is equal with minus 6.84. So we can rewrite this one as minus 18.8 minus j 6.84. Because it's a negative value, we of course replace the plus with the minus. Alright, let me put this a bit higher now. There we go, so you can see it. Now we do additions, which, as you can see here, it's easy in rectangular form, and subtractions are also easy. So we do c1 plus c2, which is equal with 4 plus 6. You add in the real numbers, which are the simple ones, plus j 8 plus 2, and then that will simply be equal with 10 plus j 10. Now let's do the next one, which is again it's another addition, but this one has a negative number in the addition. So c1 plus c2 is equal with, then 6 minus 12, because plus and minus gives you minus, plus j, that will be 12 plus 6. And those will be equal with minus 6 plus 18, plus j 18. There you go. So if you wonder like how this looks in a graph, because complex numbers can also be solved in a graphical method, this is how they look on a graph. There you go. This is for the first one, where c1 was 4 plus 8j, and c2 was 6 plus 2j. You combine them together and to give you c1 plus c2, which is 10 plus 10j, the perfect square. And you can do the same for the second one as well. So c1 was 6 plus 12j, and c2 was minus 12 plus 6j. The j's were both positive, so both of them went up, but because c1 on the positive side wasn't big enough to overcome c2, then instead of like going to the positive, it just shifted by 6 units that way, so that's why it's minus 6. Again, I suggest you to do it like the mathematical way, which is like just do it on paper, just to apply the formula and calculate, instead of doing the graphical method, because the graphical method will take you a lot longer, and also it's not really useful, because again, when you do this in a proper AC circuit, you'll need to apply like conversion and addition and everything like 10 times at least. So it's not very efficient to do it in the graphical method. That's why I did the graphical method only for the two of them, for the pluses, and the minuses or the multiplications, because it's not very useful in those cases. But anyway, so that was the addition. Now let's go to subtraction. Let me just put it a bit lower. There you go. So yeah, we can do c2 minus c1. So c2 minus c1, which will be equal with, again we pick up the real numbers, which is 2 minus 8 plus j, and in j it's like 8 minus 12. Then that will be equal with, so that will be minus 6, and then 8 minus 12, that will be minus 4, so that will be minus 4j. So that's the answer. Again, very simple to add them in rectangular form, or to subtract them as well. In rectangular form, it's a bit hard is to multiply them and to divide them, but even that is possible if you know the formula. But anyway, so c2 it's c2 minus c1 will be equal with, in the bracket, minus 4 minus 6, let's close the bracket, and then plus j 10 minus 6, and that will be equal with minus 10 plus j4. And then we have another value where this one, instead of both of them being in the negative sides, g is in the positive side and it's at -10, meaning that this value will be somewhere around this area where the x is -10 and the j value is positive, instead of being somewhere in the down area where it's both of them are minus net values. The graph is more like to show you how they look like, and yeah, and basically that's it really. But anyway, now let me show you how you can do subtraction and addition in a polar form. Remember, you can do them only when they have the same angle, and because they have the same angle in here, we can do them. Well, these ones have the same angle, but I'll show you how to do it in a second. But anyway, so let's do this one. In this one we need to add them together, so it'll be simply the 460 degrees plus 6 angle of 60 degrees, it will simply be equal with 10 the angle of 60 degrees. Very straightforward. Now for this one it's a bit more complicated because we need to convert the 0 degrees to the 180 degrees. And when you do a conversion like that, when you do z angle plus or minus 180 degrees, then you need to replace you need to do the opposite of the sign in front of z. For example, if z was minus and you add or subtract 180 degrees, it becomes positive. Or in our case, if it was positive and we add 180 degrees, then it will become negative. So for angle 0 degrees, it's also equal with minus 4 angle of 180 degrees, because we added 180 degrees. And now because they have the same angle, we can add them together. So that will be minus 4 angle of 180 degrees minus 8 an angle of 180 degrees, and that one will be equal with minus 12 an angle of 180 degrees. And remember, like, this is a trick really, because we can apply this one with other angles. For example, with a 60 degrees angle, if this one was 60 degrees and the other one was, let's say let's say this one was 60 degrees and this one was 240, I think it will be. Yeah, if this one was 240, we can add 140 to this 60 degrees, change it from a plus 10 to a minus 10, and then we have the same angle, so we can apply the polar form. But well, of course that doesn't always happen. And why is that? Well, it's because you might get like 53.13 and then the other angle it's like 55. So you can't really add or subtract 180 to it, because it will never give you the same number as the other equation. So yes, sometimes you get around and use this trick here to like add and subtract polar form numbers, but it doesn't always work, and most of the time doesn't work. So when it doesn't work, you have to convert it to a rectangular form so you can add them or subtract them. Alright, let's go to multiplication now. So C1 is equal to 4 plus J6 and C2 is equal to 10 plus J20. Now multiplication rectangular form, it's a bit more complicated as you saw here. So let's follow this one, because even I don't know this one, because I don't really use it that often. So C1 times C2 is equal with X1 times, actually no, let me put a dot for multiplication, times X2 minus Y1 times Y2 plus J y1 times x2 plus x2 times x1 times y2. There you go. And then this one will be equal with, so x1 that will be 4 multiplied by x2 that will be 10 minus y1 that will be 6 multiplied by y2, which is 20, close the bracket, plus j and y1 that will be 6 times x2 that will be 10 plus x1 that will be 4 times y2 that will be 20, and then that will be equal with, so let's see here, 4 times 10 minus 6 times 20, that will be minus 18, and then the other one, 6 times 10 plus 4 times 20, that will be positive for sure, that will be plus j 140, and that is the number, when you multiply those two rectangular numbers, you get the number of minus 80 plus j 140. Alright, now let's do the next one, which is this one here. Let me like put it more that way here. There you go, so you can see it clearly. Okay, that's perfect. Okay, so again, it's the same formula, so it'll be c1 times c2 equal with x1 multiplied by x2 minus y1 multiplied by y2 plus j y1 multiplied by x2 plus x1 multiplied by y2, and that will be equal with, so x1 that's minus 4 times x2 that's 8 minus y1 that will be minus 6, and minus with actually it's yeah, it will become a plus, won't it? So it will become plus 6 times, and then 12 here, close the bracket, plus j, then y1 that will be minus 6 times x2, which will be 8, and then plus x1, which is minus 4, so that will become minus 4 times y2, which is 12. Alright, so the no, which is minus 12. So this is minus 12 as well, then this one would be minus 6, so it would still give it a plus, I think, but this one it's a minus as well. Alright, so let's start solving it now. So let's put double bracket, so minus 4 times 8 minus, open another bracket, minus 6 times minus 12, close this bracket as well, that gives us minus 104. Alright, and now we do bracket again, minus 6 times 8, close the bracket, minus, no, this is a plus, and then to be another bracket, minus 4 times minus 12, and that will give us 0. That's strange, isn't it? Giving us 0. But anyway, so it will be plus j0. And because this is 0, you may say like, well, then it's wrong, because is it possible to get a j value that's equal to 0? And the answer is actually yes. Funny enough, like if j is 0, that means that the component is actually a resistor, because the resistors, they don't have j values or angle values, because they just copy what they get in from the source, you know. So that's why the j0, if you get the j0, then think about like, okay, that component is actually a resistor. Yeah, or maybe like you try to calculate the sources and you get the j0, and that means, okay, so if it's j0, that means that the source didn't have an angle in the first place. And if you get the j0 but the source has an angle of 60 degrees, let's say, then yeah, you did something wrong in your calculations, because again, you're supposed to get a number. You get 0 only if there is no phase, you know, if only there is like no plus or minus 60 degrees or any other number. But anyway, so this one was the first one. Let me get ready the second one, which is this one here. Okay, and this one is multiplication in polar form. And multiplication in polar form, and it's again really easy compared to rectangular form, because again the formula is simply like c1 multiplied by c2, it's equal to z1 multiplied by z2 angle 1 plus angle 2, which is equal with so that'll be 10 times 20, so that'll be 10 times 20 angle of 40 degrees plus 60 degrees, so that will be equal with, that's 200, isn't it? I think it is. Let's see, let's check to make sure. 20 times 10, yeah, 200, so that'll be 200 times 100 square angle. So that's the multiplication in polar form. And you saw like this one was a lot easier, we didn't do any mistakes, you didn't like almost did a mistake like the other one where they didn't put the negative one number. So it's a lot safer to do a simple calculation like this one. Let's go to the next one, which has negative numbers. So C1 times C2 is equal with again Z1 times Z2 angle 1 plus angle 2. That one will be equal with minus 4 multiplied by 14 angle of minus 80 degrees plus 240 degrees, and then that one will be equal with, so 4 minus 14, what's that? Is it like 456, isn't it? Minus 56 minus 4 times 14, yeah, minus 56. And then the angle here, that'll be 240 minus 80, that'll be 160 degrees. There you go. Alright, so that was multiplication in polar form, very simple. Alright, okay, let's keep going. Actually, like, pause here for some water or anything like that. Let's get over this one quickly, because we are about halfway done. Okay, now division, which was the next one on the formula list. This division rectangular form, division in polar form. We start with the rectangular form, which is the hard one, because in rectangular form it will be something similar to C1 over C2. It's equal with x1 times x2 plus y1 times y2 over x2 squared times y2 squared plus j y1 times x2 minus x1 times y2 over x2 squared plus y2 squared. And there we have it. Now we just need to replace the numbers, so that will be 2 times 8 plus y1, that will be 8 times 10, x2 squared, the y squared, so that will be 8 squared times 10 squared. No, that's plus, it's not times, plus. See, there you go. Already, like, mistake I have done and ruined the entire thing when doing straight away rectangular form. Okay, plus j, that will be y1, that will be 8 times x2, that will be 10. No, x2, that will be 8 again. So it will be 8 times 8 minus x1, which is 2, times y2, which is 10, divided by, again, the same number as here, 8 squared plus 10 squared. Then that will be equal with, so let's see here, 2 times 8 plus 8 times 10 over 8 squared plus 10 squared. The first one will be 0.6, it is, so 0.6. And now let's do the second one, see if it's a plus or minus. So 8 times 8 minus 2 times 10 over 8 squared plus 10 squared. That one is like 0.26, so plus j 0.26. And there it is. This is the answer. So 0.6 plus j 0.6. Alright, now we'll do another one, but this one has negative numbers inside of it as well. So it will be C1 over C2 equal with x1, that will be minus 8 times x2, which is 12, plus y1, which is minus 16, times, and then y2, which is minus 2, all of it over, when they are squared, then they'll be positive anyway, so we can put like 12 squared plus 2 squared plus j, and for j it will be y1, so y1, that will be minus 16 times x2, which is 12, minus x1, which is minus 8 times y2, which is minus 2. And again, all of it over the same number, 12 squared plus 2 squared. Then that will be equal with, so let's say here, minus 8 times 12 plus minus 16 times minus 2 over 12 squared plus 2 squared. That one, it's minus, okay, so it'll be minus 0.43 And now let's do the next one, which is minus 16 times 12 minus 8 times minus 2 over 12 squared plus 2 squared. That will be minus 1.4. So minus j 1.4, and those are the answers. Alright. Okay, so that's the division when you're using rectangular numbers. Again, very complicated, like unnecessarily complicated, to be honest. So now let's do it. Let's do division in polar form, which is the a lot simpler way. Because it will be simply C1 over C2 is equal to Z1 over Z2 angle 1 minus angle 2. Alright, and that one will simply be equal with 30 divided by 4 angle, then this is the angle 1, which is 20, minus angle 2, which is 14, and that one will be equal with, let's see here, 30 divided by 4, 7.5, angle of minus 6, no, angle of 6 degrees. And there we have it. This is simply the division in polar form. And again, we can easily do it even though we have negative values. You can do like C1 over C2 is equal with 16 over 32, angle of 240 degrees minus 100 degrees, and then that one will be equal with, so that will be 0.5 angle of, and that one will be minus and minus, that makes it a plus, so that will be 340 degrees. Okay, and there we have it, the division in polar form. Alright, I'll pause in here, I'll have a sip of water, and then we'll do the last two problems, which is not in the formula page. They are made up problems to show you how they look like in an AC circuit, or similar to how they look like in an AC circuit. Okay, now this will be the two exercises, and they're supposed to like using complex numbers in circuits, and to show how you'll use them in a circuit. Alright, don't worry, the frequency here doesn't really matter. What matters are these two values, which is VA is equal to 50 sine 377 plus 30 degrees, and VB is equal to 30 sine 377 plus 60 degrees, and the voltage again is simply V plus VB like in a normal circuit. I was thinking about making them into resistors, but that doesn't really make sense because they have phases, you know, this side's got plus 30 degrees, this one got plus 0 degree, 60 degrees. So we need to find in the total EN value. So how do we do this? Well, it's very simple, but there are like a few steps that you need to follow, which is the very first one is to multiply by 0.707, basically make it into an RMS value. So then that'll be VA is equal to 50 sine 377 T plus 30 degrees, and then you multiply that one by 0.707. You basically only multiply the 50 degrees, and that one will be converted in 35.35, an angle of 30 degrees. So the way to think about it is like when you multiply by 0.707, you kind of like making a polar form, because it'd be 35.35 at an angle of 30 degrees. You do the same thing for the next one, which is VB. It's 30 sine 377 T plus 60 degrees times 0.707. You multiply them again, like you multiply 30 by 0.707, and that will be equal to 21.21, and the angle stays the same, which is 60 degrees. Alright, so now that we convert them, what do we do next? Well, of course, we add them together, because that's what the problem is asking us. It's asking us to add VA and VB together to know EN, but to know the total voltage. But remember that the first rule is that you can add polar forms, there you go, so you can see it, that you can add polar forms together that are having different angles. And as you can see from this one here, it clearly has different angles, because this one is 30 degrees and this one is 60 degrees. So what we can do is we can convert both of them into rectangular form, so we can add them together. So then VA will be equal with 35.35, angle of 30 degrees. Therefore X will be equal with 35.35 cosine of 30 degrees. That's equal with, actually I have it here and I hope this is correct. I don't want to redo them just because I have the wrong notes, but that'll be 30.61. And then you do the same for y to know the y value, 35.35. You replace the cosine with the sine, 30 degrees. That one will be equal to 17.68. Therefore VA will be equal simply with 30.61 plus J 17.68. It's a plus again because it's a positive value. Now we know the value of A, rectangular form. Now we need to find the one for B, a rectangular form. So VB will be equal with 21.21, angle of 60 degrees. Therefore X is equal to 21.21 cosine of 60 degrees, that's equal with 10.61, and then Y is equal with 21.21 sine 60 degrees, that's equal with 18.37. And then therefore we can rewrite these two values as the rectangular form, which will be 10.61 plus J 18.37. And there we have it. This is the polar form for VB. Okay, so now because they are in rectangular form, we can simply just add them together. So VA plus VB is equal with 10.61 plus 18.37J. It doesn't really matter because we add them together, it's not like we take away them. That'll be 30.61 plus J 17.68, and when we add them together we will get the number 41.22 plus J 36.05. And you may say like, okay, so is this the answer? Is this the final answer for it? And the answer is no, unfortunately. We can't really use this value here because it does have an angle. We don't know at which point of the phase the total current is in. So this one is for the E in, by the way. So then we need to convert them, and we convert them by doing z square root x1 plus y squared. That will be equal with 41.22 plus 3.605, both of them squared under the square root, and that will be equal with, and I have it written down here, that'll be, no, that's 36.05. That will be equal with 54.76. This seems alright. And now the angle tan is equal to 10 minus 1 y over x, which is equal with 10 minus 1, and the y value will be 36.05 over 41.22, and then that one will be equal with 41.17 degrees. Very important to remember. So that would be 54.76 at an angle of 41.17 degrees. And you may say, okay, so now this is the final answer. This is the voltage, isn't it? The total voltage. And yes, this is the total voltage in RMS terms, but maybe you wanted to have the proper total voltage, which is in like normal terms. And don't worry, the angle stays the same. You don't need to do anything with the angle. Like the angle will always be 41.17 out of phase, But to know the actual value, like the value that it's actually inside EMM, Einstein, and the and the angular velocity value, you need to do square root 2 multiplied by 54.76 and then that one will be equal with 77.43, and there you have it, 77.43, no, EN, the total voltage, is equal to 77.43 sine of 377t plus 41.17 degrees. And that's how you use complex numbers to solve a very simple AC circuit. And again, it's very simple because, sorry about that, my sister walked in the room. But anyway, so yeah, okay, so that's the answer. It will be 41.17 out of phase, and the peak voltage will be 77.43. And it's a bit strange, I know, because it's not the value of the peaks added together, it's not 80 volts, and it's not either the value of like the angles added together, or one of them decoming from the other, because it's a number which is simply random, which is 41.17 degrees. But trust me, this is the correct answer, because this is the method you use to calculate AC circuits. You can really calculate them without using complex numbers. They are very important for you to understand them and understand how they work in a circuit and how to calculate them in a circuit. We'll have a lot more examples next lesson with the AC, but yeah, for now this is all of it. Alright, this one is the first one, don't worry. I have another one which you may not like the idea that I have another one ready. Let me see, where did I, there it is. And this one is different from the previous one, because this one is about current, and also it's about current that splits into currents in I1 and I2. And you can already see like the total current has an angle of plus 60 degrees, and this one has no angle out of phase. So this one is perfectly in phase, which is probably a resistor, and this one is some other component because it's not in phase. Alright, so, and also we know that I total is equal with I1 plus I2, therefore I2 is equal with the I total minus I1. So we simply have to take away I total by I1. But again, remember like the steps. The first very important step is it's IT is first to convert it in RMS value, so that'll be 120 times 10 to the minus 3 times 0.707, and then that will be equal with 84.84 milliamps at an angle of 60 degrees. And you do the same for I1 as well, which is 80 times 10 to the minus 3 times 0.707, and then that will be equal with 56.56 MA at an angle of 0 degrees. So basically there is no G value in this one really, but we still need to do them. So then IT will be equal with, so that IT 2 dots, the X value will be equal with 84.84 plus cosine 60 degrees, which is equal with 42.42 milliamps, and then Y it's equal with 84.84, and this time multiplied by the sine of 60 degrees. That one would be equal with 73.47 milliamps, and together that will give you 42.42 milliamps in the X value plus a J of 73.47 milliamps. Alright, now we do the same one for the I1. So that will be so the X value will be equal with 56.56 times cosine of 0 degrees. That one will give us 56.56 to maintain it, and the Y value is 56.56 times sine of 0 degrees, and you already know that this is 0, so that will be simply 0. So the answer for this one, that will be 56.56 milliamps plus J0. So basically when we take them away, we'll do I2 which is equal with IT minus I1, and that one will be equal with 42.42 minus 56.56 plus J 73.47 minus 0, and that will be equal with minus 14.14 milliamps plus an angle of J 73.47 milliamps. And there you have it. We even did a subtraction, and we did that one because it's a current split. Now, as you know, we need to convert this one again in polar form so we can get like the angle, and then we'll need to convert it from the RMS form to the normal form to give us the peak current. Alright, so then let's see. So Z will be equal with square root 14.14 squared plus 73.47 squared over square root, which is equal to 74.82 milliamps. And now the angle is equal with 10 minus 1, 73.47 divided by 14.14. And remember, this is a minus because 14.14 is a negative value. It's a minus value, which is equal with minus 79.1 degrees. And there we have it, we have the angle as well. So then I2 is equal with 74.82 milliamps at an angle of minus 79.1 degrees. All right, and now this one is like in the RMS form. So now we're just making it to a normal form. And again, like it might seem confusing, but it does actually work. Like you may think, well, there is no way for it to work, you know, this one is minus 79.1 in the phase, while this one is plus 6 degrees in the phase. There is not really a direct way that I can prove it, you know, like I don't have the stuff here at home to build a circuit and show you that it actually works. But believe me that this is the right answer. This is how you calculate them, and this is how you get your values. It may seem strange because I think that's why actually AC circuits are harder than DC circuits. In a DC circuit, they use natural numbers, you know, they use normal numbers that can just add, subtract them. You can see like beforehand, you can go like, oh, okay, this number is good because you put the reflex with it. While on complex numbers, it's a lot more complicated because like, yes, you can get like, you can have 3 positive values and then you do the calculation and you get the negative angle and you go like, well, how is this possible if I have 3 positive values that I added them together? And again, remember that complex numbers are named complex numbers also because they are harder to figure out. It's hard to like see it from beforehand, you know, to calculate it in your head and do it quickly. But anyway, so just believe me that that's the answer. It's minus 79.1. Or if it bothers you so much, you can like revert it, let's say, or you can do like minus 74.82 milliamps, and then you just reverse the angle, you know, you add the 180 to it. So what, that would be like 100.9 degrees. You can do it like this way as well, but to be honest, like this one bothers me personally even more because it's a negative current. So does that mean that all the current goes through I1 like this, and while all the current from I2 just comes back in? But anyway, it doesn't really matter here. It will matter more when you do like the proper exercises, because when you do a proper circuit, we can also check our answers between them, because like, okay, you think you got the right voltage, but if it doesn't give you the right current as well, that means you did something wrong in your calculation, you applied the wrong calculation. Alright, let's keep going then. So this is in RMS form. So now let's do it in like normal form, which is simply do square root 2 times 74.82 milliamps, and that one is equal with 105.8 milliamps. So then I2, the final answer is that it's equal with 105.8 milliamps sine of what was it? Wait a second. So we don't know the W value for them. Okay, that's fine. Sine WT, and then it will be minus 79.1 degrees. If this was the other way around, if you use the minus value here, that would be a minus here, and then it would be the plus 100.9 degrees. Anyway, so this is the final answer for I2. This is the value that I2 is equal to. There you go. And this will conclude the lesson for this week. Alright, so that would be everything. I guess I'll see you next time with proper AC circuits that we're going to use. And don't worry, I'll try to go quickly through AC as well. There's a lot to cover in AC as well. That's why I'm taking my time with it, because it's very easy to get lost in it, you know. It's very easy to go like, well, how do I actually do this, or how do I do that? That's why I like to do many examples of AC circuits. But anyway, and when we do AC circuits, we'll start with the series one, which is the easiest one. And in that one, we are going to use all three of them at the same time. We are going to use resistors, we are going to use capacitors, and we are going to use inductors. We still have like a short introduction. I'll just do a short introduction, which is like a simple circuit between like one resistor and one capacitor, or one resistor and one inductor. But overall, we are going to like try to cover as much ground as possible with it. Because then therefore we are going to go to the next one, which the next one will basically be parallel, and after parallel we do series in parallel, and after that we do network analysis with AC circuits this time, which is again, it's your like superposition or node or any other formula like that. Anyway, thank you for watching this video as well, and I'll see you next time.